Welcome to Math with Mrs. Bibb. I noticed there were a couple of problems in your assignment that may not have fit exactly like the ones that were provided, the videos that were provided of examples. So I want to do a couple of extra examples just to show you, number one, how I expect your work to be shown, and number two, what happens when there are special solutions with inequalities. And I think you'll be okay with these special solutions as you have encountered special solutions with the linear equations. So I think you'll be okay with this. All right, so I wrote these here to show you that it doesn't always work out that you get a nice solution like x is greater than 4 or y is less than or equal to negative 12. And let's just dive into this example. Okay, what am I going to do to solve? I'm going to keep the left side as it is, bring down my inequality symbol. I'm going to distribute this negative sign. 8x, negative 1 times 5x is negative 5x. Negative 1 times positive 1 is negative 1. And then plus 2x. Next, I'm just going to combine like terms on the right-hand side. So 5x minus 12 is going to be greater than or equal to 8x minus 5x is 3x, and 3x plus 2x is 5x. And then 5x minus 1. The next thing I would do is to move my variable 5x minus 5x, 5x minus 5x, oh, I don't have a variable any longer. I have this statement, negative 12 is greater than or equal to negative 1. So what I have to decide is this is a true statement or a false statement. Is negative 12 greater than or equal to negative 1? Well, it is a false statement, which means there's no value of x that you could select that would satisfy this equation, that would make this equation, this inequality, a true statement. So that means my answer is no solution, and I don't think you're asked to graph these on a number line, but if you were, you would draw a number line and you wouldn't shade any of it. No solution, that would be your answer. No solution, there's nothing that you can put there. Okay, for the next one, I'm going to distribute on the left and distribute on the right. So I have 6x minus 12 plus 1 and less than or equal to 5x plus 15, so I'm distributing the 5, plus x. Next, I'm going to combine like terms on the left and combine like terms on the right. There's really no work you can show for this. It's understood mathematically what you're doing. So 6x minus 11 is less than or equal to 6x plus 15. And let me move my camera down just a little. Hope I don't disturb. There we go. I'm sorry, my lighting is bad, so just trying to compensate for it. Okay, now let's move our variable. So subtract 6x. Negative 11 is less than or equal to, and look, both 6x's are gone, 15. Is that a true statement or a false statement? Well, this one is true. Negative 11 is less than or equal to, it's less than, but less than or equal to, that means it's one or the other. 15, so that's a true statement. Therefore, my answer is infinitely many solutions. That means that no matter what solution I would select for x, it would make this inequality a true statement. So to graph on a number line, you would shade the entire number line. Don't want to make my iPad come off of its stand. Okay, so that would be the solution to that problem. I hope that helps if you're struggling with those that work out strangely. Have a wonderful day.